I hate it when you guys miss percent change problems. It's not exactly the easiest thing to remember for a lot of people, but it's the kind of problem you're going to kick yourself on because you feel like you should remember it. You've done it a lot in lab sciences, you've done it some in math, and you really ought to know it. It is harder to remember, but there are a couple of tricks to make it easier, and there's a couple ways to actually do it. So let's talk about why it works the way it works. Percent change is all about figuring out how much something has changed from where it was. Okay? So we compare where it is now to where it was, final minus initial. We get that difference to tell us in absolute terms how much it's changed. Right? Now, if final is less than initial, we'll get a negative value, and that makes sense because we can have things shrink over time. We can have negative percent change. If it's bigger, we have positive percent change. If it's the same, we have no change. That gets divided. That difference gets divided by initial because that's what we're referring back to. We want to know how much it's changed from where it was. Okay, let's look at the little sample problem. We're going to work this both ways. Let's start with this way. Sam grew from 20 and a half to 23 inches. Okay, so that means she finished at 23. She started at 20 and a half. And again, 20 and a half goes on the bottom. You do the math on this, you get 2 and a half over 20 and a half. That equals 12% and some change. Rounds to 12%. Most common mistake on this is to say it's C, 112%. That's actually what percent 23 is of 20 and a half. It's not the percent change, but that's another way you could look at it, another way to work it. To do it that way, you use our old friend, part equals percent times whole. And if you haven't watched the first video on percents, I really encourage you to do so. It may seem Mickey Mouse to you, but I see all kinds of people that are really great test takers miss these questions, and they really should. So we're looking for percent, right? So we're going to plug in our whole. Whole is before the percent's applied, so that's 20 and a half. Our part is 23, and we're solving for percent. Divide by 20 and a half, and we'll get 112, or 1.12 and change. So that's what percent 23 is of 20 and a half. Remember, part can be bigger than whole. So to find how much that's changed, we just subtract 1 from it. Or we can look at it this way, 112% minus 100% is equal to 12%. Again, I'm rounding off the little decimal that goes on the end of that 12%. But that's a second way to do it. Find what percent the final value is of the initial, and then subtract the initial, which is 100%. So 2 ways to look at this. Use whatever is best for you, but stay consistent because this is something that you don't want to flip back and forth on because it's easy to forget. There's some good practice problems on this in the problem set. And check out probability. It's really the closest related topic.